हरि करना।
Now let's look into the most important distribution for a data scientist, which is binomial distribution. So before I explain what is binomial distribution, I would like you to explain some brief about that. Then we will jump into the understanding of the formula in deep. Okay, so a binomial distribution, we can say that yes or no outcomes lie at the heart of analytics, since they're often a culmination of a decision or other process. Buy or don't buy, click or don't click, survive or die, and so on. So, central to understanding the binomial distribution is the idea of a set of trials. So, each trial having two possible outcomes with definite probabilities. For example, flipping a coin 10 times is a binomial experiment with 10 trials. So, each trial having two possible outcomes, heads or tails. So, such as yes or no, or 0 or 1 outcomes are termed binary outcomes, as and they need to have a 50-50 probabilities. Any probabilities that sum to 1.0 are possible. So, it's conventional in statistics to term the one outcome the success outcome, the one no in quotation marks, the one in quotation marks outcome as the success outcome. So it's also common practice to assign one to the more rare outcome. So use of the term success does not imply that the outcome is desirable or beneficial, but it does tend to indicate the outcome of interest. Here the success means it indicates that that's outcome of interest. That's it, nothing else. So for example, loan default or fraudulent transactions are relatively uncommon events that we may be interested in predicting. So they are termed ones or zeros. They're termed as ones or successes. So that's what is our binomial, some of the terminology. So in this, the most important terms are trial, an event with a discrete outcome. That's what we call it as a trial. A coin flip is one, no, that's one example. Success, the outcome of interest for a trial. And binomial, let me put it in writing so that it will be much easier for you. So binomial distribution. So trial, an event with a discrete outcome, or an event which is done with a discrete number of times. Then the success, the outcome of interest. It doesn't tell about failure or success. It talks about the outcome of interest for a trial. Outcome of interest for a trial. Then normally the synonym for this is synonym synonym for this is normally one they used. Then binomial. What does a binomial mean? So binomial is nothing but having two outcomes. Simple. That's what is binomial. Binomial, by to nomial. Okay. two outcomes. Having two outcomes is called binomial. Having two outcomes is called binomials. And examples, uh, yes or no, 0 or 1, or you can also call it as a binary binomial, also can be called as a binary. So next we have binomial trial, which is a trial with two outcomes. A trial which has only two outcomes is known as binomial trial. This can also be called as a Bernoulli trial. Bernoulli trial. Then final one, the binomial distribution. Binomial distribution. Binomial distribution. The distribution of number of successes in X trials. This is also known as Bernoulli distribution. Okay, so these are the most important terms of binomial distribution. A trial success, binomial trial, and binomial distribution. Now let's get back into our work. So what is the binomial distribution now? Because we have seen the terminology. So now what a binomial distribution is? So the binomial distribution is a common discrete distribution. It's very important. Binomial distribution is a discrete distribution used in statistics, whereas continuous distribution is normal distribution. Okay, a normal distribution is a continuous distribution, and binomial distribution is a discrete distribution. So the binomial distribution is a probability distribution that describes the number of successes in a fixed number of independent trials. So each with the same probability of success. So as I've told you, it's a discrete function, which means that it takes on a finite number of possible values. Now, how do you calculate this? How do you calculate the respective probability? So the binomial distribution is characterized by two parameters. One is the number of trials n, and the other one is the probability of success p. Okay, two parameters, one the number of trials and the probability of success. So the probability of getting exactly k success in n trials is given by the following formula, and this is what is the core of binomial distribution. This is also called as a binomial function. So p of x and p of x, if it is n trials are done with the probability of p success. Okay, n, you know, the number of trials, and p is the probability of success. Okay, so now let's see what is a respective term that designates. So n is the number of trials, or you can say number of occurrences, and x is the number of successful trials. That's what number of successful trials, x, and p is the probability of success in a single trial, and q we did not use here. So normally 1 minus p can be called as q. So when we did it in engineering, we have studied in such a way that ncx p power x 1 minus p, in spite of 1 minus p, we have studied q power n minus x. So their Q is the probability of failure in a single trial, but we are not worried much about that. So that's why we have used 1 minus P. And the most important one, NCX, we can call it as N choose K, N choose K, or you can call it as N choose X. So so here we are using kx. So either you can use x, or you can say k also. So I will be using interchangeably. Sometimes I say x, sometimes I say k. Don't get confused. So NCX is the combination of n and x. A combination is the number of ways to choose a sample of x elements from a set of n distinct objects where order does not matter. If order does not matter, that is combination. If order does matters, that's permutation. And replacements are not allowed. Without replacement, if it is done, a combination which is done with a replacement, it is called bootstrapping. Bootstrapping. If it is without a replacement, obviously that's a combination. So note that NCX or N choose X. N choose X is equals to N factorial divided by R factorial, or divided by R factorial times N minus R factorial. So where factorial is nothing but if it is 4 factorial or 5 factorial, it will go on N times N minus 1 times N minus 2 times N minus 3 times N minus 4 times, and so on and so on, N minus 1 times. Okay, so finally this is what 4 factorial example, 4 times 3 times 2 times 1. I hope many of you might know about this. So this is what is the one which calculate the probability of getting exactly uh, k successes or x successes. Here, I told you the k and x. K, you replace the k with x. So probability of getting x successes in n trials is given by this formula. Probability of getting x successes in n number of trials is given by the in given by, and the p is the probability of success in a single trial, and this is what the formula you do. So I'm repeating this. The probability of, you see here, a probability of getting exactly x successes in n trials, given that the probability of success is equals to p, then this is what the formula that we calculate. I hope you got my point. So now let's move ahead. So some next, the mean of the binomial distribution is n times p. Remember this, n, the number of trials times the probability of success. That's what normally mean. We will prove this, not to worry about that. We'll prove this. The probability of success in a single trial, then the variance is n times p times 1 minus p, npq. So basically it's again the multiplication of number of trials multiplied by the p, probability of success in a single trial, and probability of failure in a single trial. You multiply all these things, you will get the variance. Then the most important point, the skewness and kurtosis. The binomial distribution is generally skewed if the probability of success is not close to zero point 0.5. As the number of trials increases, the distribution becomes more symmetric and approaches a normal distribution. Then we have binomial theorem, very important. The binomial theorem is a formula that provides a way to expand binomial expression, raised to a power. So it's based on the binomial coefficients which can be calculated using the binomial distribution. If you put it in a simplest way, so the binomial distribution is widely used in various fields such as biology, finance, engineering, to modern and even to the to model the probability of success in a fixed number of trials. So, in summary, the binomial distribution is a probability distribution that describes the number of successes in a fixed number of independent trials, each with the same probability of success. It's characterized by two parameters: one, the number of trials, and the probability of success. Understanding the properties and applications of the binomial distribution can be helpful for data scientists when modeling various phenomena such as the success rate of a marketing campaign or the probability of a disease outbreak in a population.